Hello everyone, this is Vani from R.M.K College of Engineering and Technology. We are going to discuss about error control coding technique in this video. Why error control coding is required? Because whenever the digital data is transmitted over the channel is subjected to various types of noise, distortion, and interference. So this leads to increase in probability of error, and it should be reduced by some method which is called as error control coding. So error control code for data integrity may be exercised by means of forward error correction. So let us understand what is the meaning of this simplified communication model, where the source is generating information, the analog information is converted into digital. So channel encoder actually adds redundant bits in order to detect and correct error, followed by modulator and then followed by channel. Up to this, it is the transmitter side, and in the receiver side, the demodulator demodulates the signal, and whatever redundant bits were added at the transmitter side are removed at the channel decoder in order to detect and correct the error. And finally, the information reaches to the user. So the purpose of adding redundant bits at channel encoder is for a need for increased transmission bandwidth and adds complexity to the system, but helps to find the error. So the error control codes are major classified into block codes where memory is required, and convolution code where memory is not required because it is bit by bit operation. And another type of classification is linear code and nonlinear code. So the linear code perform modulo to arithmetic on two code words to get the third code word. Right. So this is a simplified idea about what is block code and convolution code in error control coding. So linear block code, if we generalize, in the linear block codes, the parity bits and message bits have a linear combination, which means that the resultant code word is a linear combination of any two code words. So let us consider some blocks of data which contains k bits. Suppose this is the message where it contains k bits. So along with k bits, we are going to add check bits, right? Which are, we call it as redundant bits, whose value is n minus k bits. Actually, the total number of bits in the information after adding check bits is n bits. So the n minus k bits are parity bits. Parity bits help in error detection and error correction, and also in locating the data. So if we see here, this entire representation in linear block code, we call it as n comma k linear block code, where k bits are identical to message sequence to be transmitted, and n minus k bits are called check bits, which are otherwise called as parity. Uh, in linear block codes, the message bits are transmitted in unaltered form. If we say, if we take the transmitted information X, which is M1, M2, M3, the original message information, followed by the redundant bits which are added by the encoder. And normally in matrix representation, if we want to express this, we represent message as matrix and check bits as matrix, and the final output also in terms of matrix. So here we call it k by n as code rate, where k is the number of check bits and n is the total number of bits in the information after adding redundant bits. So what is the general representation? X is equal to m into g, where x is the code vector, m is the message vector, and g is the generator polynomial. So what is the size of G? Actually, the X matrix is with the size 1 cross n, M is with 1 cross k, and G with k cross n, right? So G is nothing but it is a combination of I and P, where I is the identity matrix and P is the submatrix. And the size of identity matrix is k cross k, and the size of submatrix is k cross q. right? So where Q is nothing but n minus k, that is check bits. So the check matrix C is represented as C is equal to M into P. So if we take an example how to apply all this matrix and how to find out code vectors, a general example is taken where the generated matrix for 6, 3 block code is given below. We have to find out all the code vectors of this code. So generator polynomial is given. So first of all, we have to obtain the P submatrix, right? So P submatrix from this, because generator polynomial, we know that Ik and P submatrix with the size of K cross Q. So obviously this part is identity matrix and this part is submatrix. Now, so easily we can separate them out. And to obtain equation for check bits using C is equal to MP, we need to apply the formula. C is equal to M, right, where M is nothing but M1, M2, M3. And we take this submatrix 0, 1, 1, 1, 0, 1, 1, 1, 0 here. So if we multiply this, right, if we multiply this and this, so M1 into 0 is 0, M2 into 1 is 1, M3 into 1 is 1. So we use modulo 2 addition here. Similarly, for finding out C2, which is matrix multiplication, we get M1 exclusive or M3. And C3, we are getting M1 modulo 2 addition with N2. From this matrix only, we are finding out the check matrix parameter. So here the Q, which is n minus k, is greater than or equal to Q. It should be greater than or equal to Q. In our case, it is 3. And the number of bits is 2 power Q minus 1. So 2 power 3 minus 1 is 7. And K is n minus Q, which is 4. So we combine now our message, check bits, and code word in order to find out the code word. So let's see how it is done. So M1, M2, M3, we use the formula which we have derived, right? So we just take, as it is 3-bit information, we take from 000 to 111, right? And the check bits we are calculating by using the formula of what we derived for C1, C2, C3. Code vector is nothing but combination of this. If all the things are combined, right, M and C are combined, then we are getting code vector. So here one of the important parameters we have to remember is Hamming code, whether the particular linear block code is a Hamming code, how we can check. The rules are the number of check bits Q should be greater than or equal to 3. Block length should be 2 power Q minus 1, that is n size. And number of message bits should be n minus Q. And the minimum distance between the two code words should be 3, right? So this is what the Hamming code's definition. Thank you.